Hello, good evening. Today is October 1st, 2022, and I'm Bhavani Thuraisingam from the University of Texas at Dallas, and I'm recording a presentation which I usually give as part of my lectures, either secure cloud computing or secure cloud computing and IoT, which also includes web services. And so I've been giving this presentation. Initially, I gave it at UC San Diego Extension, initial version, and that was a long time ago in January 2008. And that was part of a one-day lecture. And since then, I've been modifying this presentation, adapting to the particular lecture, and I've been giving this, as I said, as part of my lectures at the University of Texas at Dallas. And so now I'm going to share my screen. Okay, so the title of my presentation is Secure SOA, which is Service-Oriented Architecture, Web Services or Secure Web Services, and Secure Cloud Computing. And here's the outline of my talk. So first I'll give an overview of SOA, which is Service-Oriented Architecture, and Secure SOA. And then I'll talk about web services and web services security. And then I will discuss cloud and secure cloud, and then provide some directions. So I'm going to cover many topics and condense them and present them in one lecture. As I said, I gave a lecture just on the web services and secure web services. It was a one-day lecture, a tutorial at UC San Diego Extension. So, and I've also added material, cloud and secure cloud. So everything is being condensed into one lecture. And I'd like to thank especially Professors Elisa Bertino and Lorenzo Martino. They are at Purdue University and they are experts in web services, and they have contributed to several of the slides in this presentation. As I said, the initial version of this presentation was given as part of a one-day lecture at UC San Diego Extension in January 2008, and variations have been given as part of my regular lectures at UT Dallas since 2009. Okay, so what is service-oriented architecture? Because today we are living in a service-oriented world. Actually, even from, I believe from day one, we've been living in a service-oriented world. Only thing we didn't call it service-oriented. So service-oriented architecture views the world as a collection of services. So for instance, when I'm teaching at the university, I'm providing a service, which is an education service, or actually a teaching service. And the consumers are my students. And I'm not directly teaching the students in the sense they are not paying me, they are paying the university, and the university pays me, which means that there is a third party involved. So the university, so I'm the service provider, students are the service consumer, and the third party or the platform is provided by UT Dallas, right? And in general, when I'm giving this class, in person, I'm not using the web, although I'm using, the computers and project it on the screen and so on. But again, during the pandemic, right, I was giving lectures through the web because we were using either Zoom or WebEx. And for our university, for lectures, we used Microsoft Teams. So that was using the web. So those services are called web services. And I'm going to talk about it in the next chart. Another thing I wanted to mention is that everything is based on services, right? So for instance, we go to see our doctor, and let's say our doctor works as part of a clinic, or he or she works at a hospital. In that case, the doctor is a service provider. He or she is providing a healthcare service. We are the service consumer. We are the patients. And the third party is the hospital or the clinic. Because we don't pay directly to the doctor, we pay to the hospital or we pay to the clinic. Now, if we are going directly to the doctor and we are paying the doctor directly, then it's a two-party service. There is no third party. So as I said, we've been living in this service-oriented world, right? And so that service-oriented world has been sort of translated or transformed into the computer world, right? And so this whole service-oriented paradigm, I believe, started after the World Wide Web, sometime around the mid to late 1990s, and it has been evolving since then. Okay, so what is this SOA? So there is a service requester. Now, the service requester could be a patient, service requester could be a student, or someone who wants to book an airline reservation, a traveler. So the traveler or the service requester has to get a service from the service provider. But in general, he or she may not know who to go to. So he has to go to some sort of directory, which you can think of as Yellow Pages, right? Remember those days, we used to have this big, thick book, Yellow Pages. I believe the phone company provides. And so we will, if you want to go and get a car repaired, we will look at the Yellow Pages, and then we will find the address, and then we will drive to the repair shop. But today we don't do that, right? We don't get the Yellow Pages, everything we do on the web. So what do? So service requester wants a service. That means the client process that acts on behalf of the service requester will go to the directory. UDDI stands for, I think, Universal Directory Integration. You can check it on the web. So I don't know the exact sort of the name for everything. I keep forgetting, sorry. So it's Universal Directory Integration, something like that. So that's you can think of it as a Yellow Pages or a directory. Now that directory will have all the services or whoever publishes. So the service provider could be the hospital, or it could be the university, or it could be the, what else? The American Airlines or whatever. They publish their services. Where do they publish? On the directory. So my client will go and because they've got to find an address where to go to. So they'll go to the directory, get the address, then they will request the service from the service provider, and they will get the response, which is a travel service. Now, sometimes the service provider will ask them, do you also want a car reservation and a hotel reservation? If it's yes, then the service provider, which is American Airlines, and I'm saying American Airlines only because I live in Dallas-Fort Worth, which means the hub, the headquarters of American Airlines is in Dallas. So we are almost, we always, almost always take American Airlines. So we're sort of forced to take American Airlines because we can go nonstop to almost any part of the world. But in any case, American Airlines now becomes the service requester, and they will contact, say, Hilton Hotel to get the hotel service, and they might contact, say, Avis to get the car service, and they will bundle all the services, travel, airline, and hotel, and then give it to the service requester. So this is a service-oriented architecture. Okay, but now what we are doing is almost all service-oriented paradigm, it's being implemented on the web, right? So that's why we now have web services. So a web service is a software system designed to support interoperable machine-to-machine interaction. Just a second, I just hope that I am, just a second, I just hope that my thing is getting recorded, otherwise, because I'm not sure whether, because I was not sure whether I'm getting, I pressed the record, the sound button, right? So just a second, I don't want to spoil this. Gosh, what's happening here? Oh, let's see. Sorry, yeah, everything is fine. Now I need to minimize this. Okay, fine, good. So, sorry for the disruption. Right, so a web service is a software system designed to support interoperable machine-to-machine interaction over a network. It has an interface described in a machine processable format. Specifically, we call it WSDL, WSDL, Web Services Description Language. I'll explain to you. Other systems interact with a web service in a manner prescribed by its description using SOAP. SOAP stands for Synchronized Object Access Protocol, but we call it SOAP messages, typically conveyed using HTTP and XML, Hypertext Transfer Protocol, and Extensible Markup Language serialization in conjunction with other web-related standards. That's web service. I'm going to explain in a minute. So the source is from the World Wide Web Consortium, right, W3. The other ones, Sir Tim Berners-Lee, who heads the World Wide Web Consortium, is the one who invented the World Wide Web. Okay, so what's this web services? Let's go back to this picture. Suppose we are offering these services through the web. So, and that's what happens when we make a reservation at American Airlines through the web. So the service requester will look at the yellow pages, fine, and get all the directory, get the address, and service provider, they will have to publish, right, their services. How do they publish? In yellow pages, they will publish it in English, or American English in the US, and British English in the UK, and Chinese in China, and so on. So, but in the web world, right, you've got to have a language that could be understood by machines. So that language is Web Services Description Language, WSDL, which we also call WSDL. And that language is based on XML, Extensible Markup Language. Just like English has become, say, a common language, right? Around the world, almost everyone, not almost everyone, but that's the common language that we use, regardless wherever we go, right? Whether it be India or China or Japan or Australia or Nigeria, right? America, we speak in English. That's a common language. Many of us, our first language may not be English, but then we have a common language that we communicate, right, with each other in English. Because if we don't have a common language, we need translators. Imagine for every piece of communication having a translator. Same thing in the computer world. Before XML, we were all struggling how to communicate, like databases talking to each other from sort of disparate, heterogeneous environments, right? Like when companies merge, one company would have been using Oracle, another company would have been using IBM database. And when they merge, right, you don't want to throw everything away. You want to keep the systems as they are and then build interfaces. It was really, we used to struggle with it those days. That is before, say, the late 1990s. Then came XML, right? These are all sort of brainchild of Sir Tim Berners-Lee. And so with XML, we now have a common representation. Almost anything can be represented in XML, whether it be data or services. So what happens is service providers publish their service in an XML-like language, which is WSDL. Now, what's SOAP, the protocol? Because remember, all the communication between service requester and the directory, the service requester and the service provider, and so on, all communication has to follow a protocol. And that protocol is called SOAP. Earlier, it was Synchronized Object Access Protocol, but now we use this common name, SOAP. So what happens, the messages that are exchanged, right? But SOAP is a protocol. It tells exactly how the communication should be, but the actual messages that goes from requester to directory and requester to service provider, those messages are in XML. Okay, so that is what I'm saying here, or we are saying here. Okay, so now the web services, the World Wide Web Consortium, multiple consortium, World Wide Web, and there's another consortium called OSIS. These are standards organizations. they have come up with a framework for web services. So what's web services? It's an abstract vendor-neutral existence defined by standards organizations, and it could be implemented by proprietary or non-proprietary technology platforms. Core building blocks that include web services, service descriptions and messages, a communication agreement centered around service descriptions, and that's WSDL, Web Services Description Language, a messaging framework, right, based on SOAP, and service description, right, that services are described and presented and stored in UDDI, the directory. A well-defined architecture supports messaging patterns. Now that's the first generation. What I showed in this picture is the first generation services, web services. Again, web services, if these services are provided through the web. Now it's gone beyond web services by, say, until 2000, right? We were in the basic web services. And since then, we've been going beyond, and that's called WS Star, right? Several extensions, and they're continually, the standards organizations are continuously broadening the underlying feature set. So some of the concepts in WS Star include message exchange patterns, service activity, coordination, atomic transaction, business activities, orchestration, choreography, and so on. And an excellent reference, although it's outdated, it's still very useful to understand, is Thomas Earle's book in 2005, but several books have been published since then. In fact, I myself published a book on web services and semantic web services, add semantics to web services, and that was in 2010, I believe in December. Okay, even then, that was 12 years ago, so much has happened. Okay, so standards bodies related to web services, and again, these are the early standards bodies. Of course, the World Wide Web Consortium, W3C, and they came up with XML and a number of other standards. And OSIS, it's a nonprofit global consortium. It drives the development also of standards. And they have done a lot of work on security for the standards. And I'll talk about two of them. And WSI is the Web Services Interoperability Organization. It's an open industry organization chartered to promote web services interoperability across platforms, operating systems, and programming languages. Right, so what is this SOA security? Our approach is to implement SOA, right? Ours means not just mine, but many people implement SOA through web services. Therefore, SOA essentially is about web services security. That's SOA security. Three core specifications. One, of course, WS security. And that, you can think of it as two, because WS security has a signature. These XML messages have to be signed, and XML messages have to be encrypted. I will talk about it later. It's called XML signature and XML encryption. And then, of course, WS Star security, the second generation of technologies for SOA. And you also need single sign-on, right? Because you need identification and authentication. It's a form of centralized security mechanisms, and that complements WS security extensions. Related specifications for SOA security, and that's WS Star, the second generation. As you can see, lots of stuff. You have the basic first generation, and then second generation as security policy, trust, conversation, federation, XACML, extensible access control markup language. It's an access control model for web services, extensible rights markup language, XML key management, because you need to manage the key, XML signature, SAML, security assertion markup language to make assertions about security, .NET Passport, secure socket layer, and so on. I'll be focusing quite a bit on XACML and SAML in this lecture. Okay, so basic components of SOA security, of course, identification, nothing new. The service requester has got to identify him or herself. Authentication, that means identification like user ID. Authentication is password. A message being delivered to a recipient must prove that the message is indeed, in fact, from the sender that it claims. Authorization, once authenticated, then the recipient of a message may need to determine what the requester is allowed to do, right? What resources he or she can access single sign-on, right? That means you sign on once and you have access to all the resources. It's supported by SAML, which is what we are going to discuss, Security Assertion Markup Language, and also .NET Passport. That's some other technologies by Microsoft, and of course XACML, the access control model. Also confidentiality and integrity. Confidentiality is concerned with protecting the privacy of the message, right? Secrecy. And integrity ensures that the message is authentic. It has not been altered. And of course, it's built on top of TLS, Transport Layer Security, right? It used to be TLS and SSL, Secure Socket Layer, but now they have merged it and it's called TLS, Transport Level Security. And of course, XML, you have XML encryption for confidentiality and XML signature for integrity, right? So this is the WS Star security standards. It's built on network level security, transport level security, and then you have XML security and SOAP. And here on the side, you have policy and access control. So how to specify policies, how do you implement access control, what's the protocol, and what about security assertions? That's what we'll be focusing in the rest of this lecture for web services. But there are several other components. So in my class on web services, I do talk, and cloud, I do talk about security management, identity management, message security, reliable messaging. So these are all the standards: WS security, WS secure conversation, reliable messaging. For key management, XKMS, WS trust. And for identity management, WS federations, Liberty, SAML, and so on. Okay, so what about the implementation, various implementations for the last probably 20 years? Microsoft, of course, they have got their .NET framework, right? And it has evolved over the years, several variations. And then Sun Microsystems, it was, the company for Java and also web services, but they have been purchased by Oracle. And so Sun was, it was really a very prominent company until like the mid 2000s. So they were very much pushing these web services. And then IBM has got the IBM WebSphere. And then Oracle has got now of course, the Sun Technologies, as well as Oracle's WebLogic. And then Open Software Foundation, that's now the Apache Foundation Web Services project. So again, number of implementations. So before we go into some of the implementations, let's talk about XML encryption. It became a standard in 2002. It provides confidentiality, right? So represents a standard way to digitally encrypt the resources, separating encryption information from encrypted data, and supporting reference mechanisms, providing mechanisms to convey encryption key information. And so essentially the XML message is encrypted, right? And by the sender, and the receiver will decrypt it, and they agree upon a protocol. It could be symmetric key, and a particular implementation, it could be public key. So if it's symmetric key, they've got to agree upon, the key. If it's a public key, the sender will then, for confidentiality, the sender will encrypt the message with the receiver's public key, and the receiver will decrypt it with his or her private key. For integrity, authenticity, the sender, or that's the next one, right, for signature. So that was also in 2002, it became a standard, represents digital signature, right? And processing rules for creating XML element. These signed data can be of different types. So essentially the standards specifies what are the things that have to be encrypted in general. The XML document is encrypted with the sender's, the sender's private key. And so the receiver will decrypt it with the sender's public key. So then, and if he or she can decrypt it, then the message has not been altered. And one other thing I wanted to mention, that it's the building block, and it's going to be integrated with key management system for managing these keys, and as well as WS security. Okay, so what is WS security? WS security enhances SOAP messaging to provide quality of protection. That's the basic security: message integrity, confidentiality, and authentication. These mechanisms can be used to accommodate a wide variety of security models and encryption technologies. So WS Security also provides a general purpose extensible mechanism for associating security tokens to messages. No specific type of security token is required. You can have multiple formats. How do you get all these tokens and keys and so on? WS Security describes how to encode binary security. So certificates could be, you can use Kerberos or X509, X.509 certificates. Okay, so I'm not going to go into all these details, but again, in my class, I provide more details, not all the details about certificates and Kerberos and so on, but some details are provided. Okay, so now we talk about that box I showed you, right? That's this part, policy XACML SAML. Okay, so what is WS policy? WS policy, right, framework. It was a submission in 2006 and it's now a standard public draft release. So main goal, WS policy and WS policy attachment aim to offer mechanisms to represent various types of policies. Policies could be security policies. Policies could also be policies like an organization's email must be encrypted. No one can work more than 40 hours, things like that also could be policies, right? So policy view in WS policy, it's a policy used to convey conditions on an interaction between web services domains. The provider of a web service exposes a policy to convey the conditions under which it provides a service. So policy could be, I will provide you with a service provided, right, you pay me, you have to pay me for the service, or you've got to guarantee something, so confidential information should not be divulged and so on. A requester might use this policy to decide whether or not to use a service, because I might want to sort of share the information, or I might not want to give some of my information to the service provider, right? So then the requester can decide, do I want to use the service or not? Okay, so now we come to XACML. That is like the, you can say, the heart of access control for modern systems, open environments. Because remember, within an organization, you could use RBAC, role-based access control, and so on. But in an open environment, right? Because, you know, if you are, say, a professor, and you have some credentials, within an organization, you have a role, but sometimes in an open environment, you may want to go and present your credentials and then get access. But you can't just simply go and present credentials and say, I'm so-and-so, or I'm a professor. Those credentials have to be verified and stamped with, say, the private key of the person who gave you the credential. Okay, so for instance, if you have a security clearance, some authority would have given you the clearance. So that person's credential, the private key, should be used to stamp your credential, right? So that means we know the credential came from that person. Okay, but in the open environment, right? So like RBAC and so on, role-based access control may not work because it's not, you know, every organization is different. So what do? You go and present your credentials, and then the other organization can decide, do they want to accept your credentials, right? So that's what XACML is based on, a model called access control model called ABAC, attribute-based access control. And I think in some of my earlier lectures, remember, this is part of a series of video presentations I've been giving. Earlier, I had one presentation into 3 parts, and that was in 2018, right? Sometime, in the middle of 2018. Since then, I didn't really, for 2 years, I hadn't given video presentations. Then came the pandemic. And so I had to give all these keynote presentations through Zoom and so on. So I usually started recording the presentations and then putting it on YouTube. And then I also started recording some of my lectures and putting it on YouTube. Okay, so XACML is Extensible Access Control Markup Language. Okay, so what I meant was, in some of my earlier presentations, if you go and look at my YouTube page, you can find presentations on access control models, and in particular ABAC. Okay, so it's an approved standard by OSIS, right? Remember, the sister organization standard organization for W3C. It's a general purpose access control policy language as well as a model. It describes both the policy language and the access control decision request response language. It's fine-grained access control based on subject and object attributes. So it's attribute based. So I come and present my credentials as my attributes and the object as attributes. And then depending on my attributes, the object attributes, access is granted. And you can build it on another technology that is standard is SAML, Security Assertion Markup Language. So my assertions about my credentials, right? Those assertions are specified in SAML. Okay, so the protocol of XACML, so it has got 4 major modules, policy enforcement point. So request comes from here. The policy enforcement point sends a request to policy decision point and asks the policy decision point, okay, tell me, should I approve this request? Request could be not just accessing a database. Request could be getting access to a class, getting access to a building, getting a job, college admissions, right? That's all providing access. So it's very general. So policy decision point, we look at all the policies and various other types of information like subjects attributes and object attributes and so on, and make a decision. And the policies will say this subject with this attributes can have access to this object with this attributes, these attributes. And so the policy decision point will make a decision and then transfer the decision or inform policy enforcement point, yes, no, and so on. So here is the roles. Policy administration point creates security policy. I call it access point, is administration point. Creates security policy, stores this policy, and so on. That's PAP. PAP, policy enforcement point, performs access control by making decision requests and enforcing authorized decisions. Eventually, it's PEP that enforces the access. PIP, policy information point, serves as a source of attribute values, right? Or the data required for policy evaluation. And the policy decision point evaluates, right, from PAP information it got from PAP and PIP, right? It will make a decision and give it to PEP. Note, the PEP and PDP could be contained within the same application or distributed across multiple servers. Okay, so what's the format here? Client makes a resource request to the server, PEP is charged with access control. I'm sort of repeating what I said earlier. In order to enforce AC policies, PEP will formalize the attributes described the requester at the PIP and delegate the authorization decision to PDP. Applicable policies are located in the policy store managed by PAP and evaluated at the PDP, and other information like attributes by stored in PEP, and all that is used to make a decision. So the request is of the form subject, the object, and the action. So subject is requesting this action from the object. Subject could be a person, myself. Object could be a job, and action is to get the job or get admitted to a university or get admitted to a class, get a job. Response is permit, yes, grant access, permit with some obligations. You can get the access, you can join my class, but you've got to pay me. Deny, no, you cannot come to my class, or you cannot attend my class. Not applicable, PDP cannot locate a policy whose target matches the required resources. Indeterminate, some sort of error occurred, right? So that's the protocol. And this, I believe, was the OSIS implementation. I think it was a Sun implementation. One thing I'm still confused is why this is one. I should say that this is one, right? Because the access requester will get the access from PEP. Some or other, they say, in this picture, they are saying PAP, policy access point, will give the policies to PDP. But first is getting the request, and then PEP will give that request to the context broker, will go to PDP. PDP will get the policies, And then to the PIP, it will get all the attributes, subject attributes and object attributes. And then from the environmental conditions and so on. And then we'll make a determination and then give that to the PEP. And any obligations, PEP will ask, for the obligation service to make sure they have paid the fees and so on. And then access is granted. So I would say, right, that this would be 1, 2, and I don't want to mislead you, but this is my understanding, okay? And then you go to 3 and the request, and this could be like 4, right? The policies, and then it'll go and get the queries, the rest are okay. But why do we have to get the policies first? Or maybe the PDP wants to just store all the policies, but then how will it know the relevant policies? So that's a question why they mark this 1. Okay, so this is the data flow model. Fine. Now we go to SAML, because you have to make the assertions, right? That Bhavani Thuraisingam is a professor at UT Dallas, right? Or John Smith is a physician at UT Southwestern Medical Center. I'm just making up the name John Smith. Okay, so what's this security assertion markup? It's also developed by OASIS. They're all XML based, by the way, XACML and SAML. XML-based security services. SAML is a standard. Main goal for authentication, authorization, promotes interoperability between disparate authentication systems. How? It defines an XML-based framework for communicating security and identity information, authentication, entitlements, and attributes, and so on. Using available different security infrastructures, you can use infrastructures like PKI, public key infrastructure, Kerberos, remember, single sign-on, lightweight directory access protocol, and so on, LDAP. Okay, so some basic concepts for SAML, and later in a picture I'll show you, and then we'll come back to this. There is assertions are the core concept, right? They have assertions. SAML authority, a system entity that makes SAML assertions. It's also called an identity provider, and that's the asserting party. Service provider, a system entity making use of SAML assertions. So then there's a relying party, a system entity that uses received assertions, also named SAML requester. And then you have to make the bindings. Bindings describe exactly how the SAML protocol maps onto the lower transport protocols, right? They're going to bind. So that's sort of more of the implementation details. But again, the 3 parties, relying party, the relying party will ask a service provider, right? It's a service requester, SAML requester, and ask a service provider to talk to the various SAML authorities to make sure that Bhavani Thuraisingam is indeed a professor at UT Dallas, because I'm going and telling the relying party, I'm a professor. How do they know? So they've got to ask a service provider. I'm going to come back to that in a minute. But first, this chart was provided by Professor Bertino and Professor Martino. An assertion is constituted by 1 or more different statements by SAML authority, different kinds of assertion statement that can be created. So for authentication, right, the specified subject was authenticated by a particular means at a particular time, right? So for instance, the attribute, the specified subject, is associated, like John Smith, is associated with the supplied attributes. He's a professor, and he lives in Texas, and he's got, he lives in a house, right, $200,000 home, and so on. Authorization decision statement, the specified subject is entitled to a specified action. So for instance, what Professor Martino said was, for authentication, he's saying Martino authenticated with the password at 9 o'clock. Specified subject was authenticated. For the attribute, he's saying Bill is an account manager, fine, but he has $1,000 spending limit. That's his attribute, right? He's entitled to spend up to $1,000 for one-day travel. And for authorization, he says John Doe, right? He's authorized to buy a specified item. So it's not just access to a database, authorized to buy something, my spending limit of Bill, and so on. So it's a very, again, service-oriented paradigm. It's very general, not just access to resources, getting access to a job, access to money, whatever, right? Permitted to buy something. Okay, so remember this earlier picture I showed you, SAML, relying party, service provider, SAML authority. Remember that. So I'm going to come back to this. Okay, so what happens here? SAML requester, a system entity that users received assertions. So let's say Microsoft, it's a Microsoft organization, company, and somebody has applied for a job. Now, Microsoft is such a massive company, they don't have the time, right, to make all the, verify all the checks. So they contract it out to a service provider. It's a relying party, requester, a service provider, a system entity that makes use of SAML assertions. And so the service provider has to check, does the student have the appropriate credentials, the visa, student, what's that, not student visa, it's the H-1B visa or what, OTP, OTP, I think, I'm sorry, I've forgotten, right? As soon as they graduate, they get a temporary visa until they get the H-1B. So that visa, or the green card, or is a US citizen for certain jobs, right? And what about the character of the person? Does he have a criminal record, and so on? Is he legally in the United States? So service provider, and has he gotten his master's degree in computer science? So service provider will have to then talk to the various SAML authorities. So the SAML authority could be the immigration services, like what's that, ICE, is the person legally in the United States, and check all the visa situation, and then talk to the University of Texas at Dallas to see whether the person has graduated. And then the third thing could be talk to the law enforcement. Does he have a police record, he or she? And so currently a lot of it is, we are going more and more using the web, but a lot of it is done through emails or telephone calls, right? I get calls from these service providers. If some students have given my name as their, the person for reference, then they would call me. But eventually everything is going to be electronic, especially with XML and so on. The document will be sent to me, and then I've got to sign, but again, verify, right? I can't just sign, it has to be authorized, and I need to show my credentials. So the SAML authority, different authorities, right? INS, ICE, the university, police, law enforcement, these are the authorities, driver's license, motor vehicles, and so on, and DMV. And so they will, so the service provider, we talk to the authorities, get everything together, bundle it, and then give it to the service requester. And the service requester can decide whether to give the job or not to the applicant. Okay, so now we can combine SAML, SAML, and XACML, right? Because they both work together. So what do? The requester will make a request, so SAML assertions, and then the requester is authenticated, right, because of his assertions. And he has to be authenticated. So if I say I'm a professor, right, I've got to be authenticated. I've got to have my credentials stamped, right, with maybe the private key of the organization, like the university. And so once that is done, then he or she is making a request, then XACML kicks in, right? Policy enforcement point will go to policy decision point. And again, SAML is used for all the security assertions. And then an answer is given to the policy enforcement, and depending on what the PDP says, the PEP will either enforce the policy, right? Either grant the permission or deny or indeterminate or whatever. We mentioned in the XACML protocol earlier, okay? So that, I believe, right, finishes the web services part. And now I'll talk about the cloud computing. And also in some of my previous presentations, I have gone into some detail on cloud computing and how we use the cloud, especially using the cloud for sharing information securely. So I'm going to just summarize, provide a summary of cloud computing. And I'm going to have more detail, a detailed lecture on cloud computing and secure cloud computing, as well as secure IoT sometime in the future. Okay, so cloud computing, what is it? Right? It provides computing as a service where consumers rent the cloud to obtain computing power. So let's step back a little. Remember, a long time ago, right? We didn't have electricity, nor did we have water service. So I remember when I was growing up, we had a well at home. And from the well, we had an electric generator. We had electricity, of course, electric generator. The water would be pumped to the bathroom. So we had running tap water, right? But it's coming from our well. So we don't have to pay for the water, right? Because it's coming from our well. And so we had our own well, right? So now we don't have a well, right? We pay for the water service. Similarly, electricity, right? I remember I've had electricity all my life, but like 100 years ago, like my mother said, they didn't really have electricity. So what would they do? I mean, more wealthier people, they might have their own generators, electric generators, and get their electricity, right? So they don't have to pay another company, but they have to pay a lot of money for their generators. Similarly, we have to pay money for the well to dig the well. Okay, so that's what happened, right? So for computing, right, we have been, even now, we've got our own computers and laptops and so on, and we do all our computing. But for massive amounts of processing, right, we may not have enough storage power. Otherwise, we'll have room full of big computers. Instead, what we can do is rent a cloud, and cloud can provide us with the services. Right? Cloud can provide us with the computers. How did the idea, earlier they were talking about the grid, computing grids and so on. But then Amazon, they had really a sort of a brilliant idea, because I think it was in Christmas in 2005 or 2006, I cannot remember. They had so much demand. So they had to buy a lot of extra machines in order to do this processing so that people get all their presents on time. But then after Christmas, right, these machines were really being idle. So they said, why don't we rent these machines? People can rent these machines for computing. And that's when, right, this whole cloud computing. So they developed a cloud, and at the heart of the cloud is web services. They're providing this computing power to us as a collection of services, computing services. So this service is usually provided as a web service. Cloud computing also provides additional services, so platforms. So in addition to computing power, which is also operating systems and so on, it provides us with a platform like programming language environments, databases, and software, various applications such as computing, our income tax. We don't have to buy TurboTax, the latest version. We can rent something in the cloud. Only problem is, if you had to rent the cloud, we have to send all our data. So that's a bit of a problem from security point of view, right? So we can use the cloud for many other software applications. We don't have to develop the applications. We can use the applications in the cloud. Service consumers, that's like us, can rent any of the services provided by the cloud, either the platform or the infrastructure, that's the collection of computers, or the software/applications. Another important thing is data, right? Because if I'm a scientist, like physicist and biologist or chemist, I would need lots of data to test for my experiments. Each time I can't go and be buying data from people. I can rent the data, so the data I collect, I can store in the cloud. And if all the scientists can store their data in the cloud, then it'll be great for us. We can rent the data, right? In fact, Sir Tim Berners-Lee, he conceived the World Wide Web because he did his undergraduate degree at Oxford, and then he went to Geneva, Switzerland, at CERN. That's where all these top-notch physicists work. And so he was actually a programmer for them. And he felt that each one of them had their own data and they were doing their experiments. And so it was very difficult to share. And so he built this repository with what? HTTP and HTML for the physicists to share the data. And then he thought, why not the whole world share the data? And that's how the World Wide Web was formed. And then the hypertext part, right, all the links and clicks and so on, Mosaic, University of Illinois, Urbana-Champaign, they had the Supercomputing Institute, and they built the Mosaic browser, right, the Supercomputing Institute at Illinois, University of Illinois. They built the browser, which then later became Netscape. And so they merged the World Wide Web with a browser. Of course, now we use the browsers we use most often are Chrome and Mozilla. Okay, so let's get back. Service consumers can rent any of the services. Pay as you use or pay as you go. Just like gas and electricity and water, right? We don't pay for what we don't use, right? So if you use a lot of electricity, we pay more. If you don't, then we don't pay as much. So same way, as we get, you take advantage of more and more resources, right? We have to pay for them. The service is elastic. Computing platform can shrink. So if you don't need something, we may not need to rent. It's like, and if we need more, we can purchase more. So for example, it's very much in many ways, it's like an apartment building, right? Where there are several tenants. I'm not the only one who's using the cloud. Several tenants are using the cloud. Similarly, apartment building has got several tenants, and some services may be shared, right? Like the community building and community room and so on. But we all have our own apartment, and the elasticity is a little bit different though. Maybe you can think of a mobile home where you can add sort of components to your mobile home to make it larger, make it smaller, and so on, right? It's essentially about multiple tenants sharing the resources provided by the cloud, and the cloud now is called the cloud. The service provider who provides you with a cloud is a cloud service provider. And so Amazon is a cloud service provider. The cloud is AWS, Amazon Cloud, and the web services is Amazon Web Services. IBM has got the IBM Cloud. Microsoft has Microsoft Azure. There's Google Cloud, Salesforce. These are all examples of cloud. Okay, so there are different cloud models. Cloud computing, various types of services, including the following, okay? Infrastructure as a service, computing platform. Remember all the computers and the operating systems, and something called the hypervisors, virtual machines. Because what happens is that the cloud could buy like 1 million machines, or million is too much, 1,000 machines, and that's still a lot of money. What the cloud can provide, instead of 1,000, say 100 machines. And in every machine, you can put, a lot of operating systems. So you have one machine which can have Linux, it can have Windows, it can have the Apple operating system. So multiple operating systems for different purposes, right? For my financial applications, I can use one operating system. For healthcare, another. General use, a third. But these operating systems are all running in my machine, but there's only one host operating system, right? Which is, I'm using a Windows machine. So you've got to separate these operating systems. Otherwise, they can write into each other's memories, and there will be utter chaos. So that part of the software, hardware, firmware, whatever, that's separating these different host and the guest operating systems, that is called a hypervisor, or also called a virtual machine monitor. So VMware is an example of a hypervisor. So Xen, that was developed at the University of Cambridge, that's an example of a hypervisor. This hypervisor will separate these operating systems so that they don't write into each other's memory, right? So it provides separation. And so that's all coming as part of the infrastructure. Then sometimes you can say hypervisors could be platform, but and in many papers they look at hypervisors as part of the infrastructure. The platform is the programming environments, the languages and the compilers and the databases, right? The platform. And of course, software, the software applications, and the data, right? Biology data to test the experiments. These are some of the service models. Now, one thing so what are the deployment models? There is a public cloud like Amazon. Anyone can use this cloud, provided they pay. Private cloud, because of security reasons, right? Sometimes the private companies, and especially large companies, they can afford to build their own cloud. or agencies like, say, the Department of Defense, maybe they could afford to build their own cloud because they wouldn't want to use the public cloud and share all the data. Because security is a major consideration. So they build their own cloud, and that's the private cloud. But not everyone is wealthy enough to have their own cloud. So smaller companies, startup companies, and so on, they can all get together and build a community cloud. To keep costs down, a community gets together and provides cloud services to the community, not to the cloud, to the community. And then the hybrid cloud, it's a combination of public and private, right? Data that has to be private is usually stored in the private cloud, right? Extremely sensitive data, financial, healthcare data, and so on. Or in a company, say, social security numbers and such data. And other data like photographs, maybe they can store it in the public cloud, the Amazon cloud. That's a deployment model. Okay, now we talk about security and privacy. Cloud computing security is about securing the entire cloud, right? Because when they're using infrastructure, platform, applications, data, everything has to be secured, right? Including, that's the secure cloud, infrastructure, platform, software, applications, data, and so on. That's security for the cloud, secure cloud. Now, what I'm going to say is the next is very important for you to understand. Secure cloud computing is not the same as providing security as a service. Okay, so what does that mean? While the former, secure cloud computing, secures the cloud, such as the infrastructure, platform, software, data, in the latter case, security as a service, the very cloud that you are building, secure or not, can provide security services. The security services could be, it can carry out identification and authentication, or analyzing the malware, or detecting spam. So for instance, if a company gets lots of spam, or everybody wants to get authenticated, what they can do is divert all those, these are security operations, to the cloud. And then the cloud can look at the emails to see is there malware, and then delete all the malware and then send it, or quarantine those messages with malware or spam or something, and then send it to the individuals in the company. So cloud is providing a security service. Sometimes several people want to get authenticated. So the company will send everything to the cloud, they will get authenticated and then access the company's resources. Okay, so, but then what is the point in having a cloud that is not secure to do security work? So that's why you always want to have a secure cloud. So really you want to have the former, secure cloud, to provide security as a service. Now, the secure cloud can also provide numerous other services, healthcare service, right? To do healthcare applications, healthcare management, can provide financial services and so on, right? The banks can store a lot of their data and information and processing in the cloud. So the cloud can provide financial services, healthcare services, but they can also provide security services. So secure cloud is you secure the cloud, that very cloud can provide your security services such as identification and authentication, or email spam detection and so on. So it's very important to understand the difference. So what is a major barrier to adopting the cloud? And that's security and privacy. Because remember, you put all your data in the cloud, right? If you encrypt the data and if the data stays in the cloud encrypted, it's okay. Although, okay, when you get quantum computing, they can break the code. So let's not worry about that. Okay, let's not worry about quantum computing now, because we've got to rethink, you know, that's post-quantum cryptography. We have to rethink everything. But in any case, today, when you encrypt the data, especially with AE256, it cannot be broken. Okay, so what does that mean, right? That means if you encrypt the data stays encrypted, fine. Then you can retrieve the data and it comes into your organization, your machine, and then you can decrypt it, right? So that's okay. But often you may have to manipulate the encrypted data, because what's the point in storing, right? Okay, storing is fine. It's providing you with the storage. Every time you got to retrieve, it becomes very expensive and do the decryption on your own machine. it'll be nice for the cloud to do all the processing, right? So you keep the encrypted data, and then what do? You decrypt it in the cloud, and then you do all the processing and then send the result. But remember, once you decrypt it, right? Security is, forget about security. Once you decrypt it, the raw data is there, unencrypted data, somebody could hack in and then get that data. So IBM and Stanford has come up with homomorphic encryption. What it means that theoretically they have proven that you can do all the operations on the encrypted data, and then you can decrypt it. Finally, you can get the results, send only the result to the requester, and the requester can decrypt it and get the results. So theoretically, you can do all of the encryption in the cloud. Sorry, all the encryption and process the encrypted data. So you can process all of the data in the cloud is encrypted, right? Nothing in the cloud is not unencrypted. It's all encrypted, and you can do all the processing with the encrypted data. And then you send the result to the requester, and the requester can decrypt it. So then the cloud is secure, but performing operations on encrypted data is extremely time consuming and expensive. We have done some small, we have written some papers on small operations like querying encrypted data and so on, right? But large scale encryption, working with encrypted data, we are not there yet. But theoretically, they have shown that whether you encrypt it and you do all the operations on encrypted data and then finally decrypt the result, or if you want to do operations, you send it to the service provider will decrypt it and then do the operations, which is not what you want to do, because you want the cloud to do all the operations, but the results are going to be same, is what IBM and Stanford have shown. So that's very encouraging. That means we can achieve cloud security, but when is the question? And when we can do it, right, when it is practically feasible, then there will be quantum computing. So that's what I'm very worried, but let's not worry about that now. Okay, so that's the main barrier. Security and privacy considerations. How do you do identity management access control? So remember, SAML, XACML, that's the model. Those are the models: security assertion markup language, extensible access control markup language. Those are the standards that are being adopted by the cloud today, right? So that's why because remember, cloud provides us with services, and these services model, service provider, service consumer, right? So SAML and XACML work for web services, so they work for the cloud as well, but scalability is the question. So that's where some of the research is being carried out. Virtualization, that's the hypervisor part I mentioned to you. So that means virtualization, the hypervisor has to ensure that all the guest and host operating systems are secure. So there are some trade-offs. Should the hypervisor manage security, provide security, or should each operating system provide its own security? Because if the hypervisor is to provide the security, if the hypervisor is attacked, then there's no security. Then there is system security, data and application security. What about privacy of the individuals? What about compliance, right? Compliance to all the policies, HIPAA compliance, all the regulations and laws, HIPAA compliance, right? The Health Information Portability Act, right? All the patient data has to be encrypted and so on. Business continuity and data recovery. What happens if the cloud is collapsed, cloud is attacked, or cloud is down, right? Or cloud is hit by a tornado, oh gosh, or a hurricane. We just had this awful hurricane Ian, right, a few days ago, and it's just heartbreaking. So, but the cloud could be affected too, and that's what happened after 9/11 and even Katrina, right? We didn't call it cloud then, but all the business processing, right, was destroyed. So you need to have backup, right? Backup plans and backup clouds. You have to log in, maintain audit trails of all the operations on the cloud. What are the legal issues, right? What are the laws governing the cloud? What are the contractual issues? So if the service provider tells you, I'll have the cloud 24/7 for you, well, he or she shouldn't, because it's impossible to have it 24/7. Then you could maybe sue the cloud service provider if the service is down. So that's why it's always safe to say that, it's maybe 6 days a week or so many hours we will make it available, because they need some downtime, right? And they need to get some insurance, of course. There is cloud insurance, just like cyber insurance. Okay, so physical and personnel security, the physical, the perimeter of the cloud, what about the people using the cloud, right? People not maintaining the cloud, they could steal the information, right? And the cloud has to be available. So these are a lot of the considerations, security and privacy considerations for the cloud. Okay, so my last chart, web services are at the heart of cloud computing. First of all, web services. So cloud services are provided as web services. And as I said, we talked a lot about web services and secure web services, in particular XACML and SAML. They are being extended to the cloud. And there are many deployments, right, of the cloud. These are the well-known Amazon Web Services, Salesforce Cloud, Microsoft Azure, and IBM Cloud. Cloud provides various types of services, including infrastructure as a service, platform as a service. SaaS, SaaS is software as a service. You can also call it application as a service, but we've been calling it software as a service. There is DaaS, data as a service. Some people call it desktop as a service, but I'm calling it data as a service. There's also security as a service, but we can't use SaaS, SaaS, because that has already been taken by software as a service. So I don't know what abbreviation they are using for security as a service. Maybe, I don't know, EAS for security as a service, whatever. But still, security and privacy continue to be a major barrier for the successful deployments of the clouds. And so that is a major consideration. So I wrote a book, but that was in 2013, on developing and securing the cloud. But so much has happened since then, and so much more to write about, so much more to study about. And so this lecture is really important, because see, we talk a lot about cybersecurity, and now the big thing is AI and machine learning. But eventually you've got to put all these systems, security systems and machine learning systems, AI systems, they have to be deployed, like large scale applications, they have to be deployed, and they have to be provided in general as services. And that's why studying web services is so important, right? Please don't think that, like some students say, oh, I'm doing machine learning, why do I need to study all that? No, when you go and get jobs, maybe if you're in academia, maybe that's different. When you go in the real world, remember, I worked in the commercial industry, Honeywell, Mitre Corporation, and so I understand how large systems are put together. You can't just focus on one technology. You've got to take a systems perspective, right? And so these web services are really crucial. And cloud, right? Again, web services, they are at the heart of the cloud, because cloud services are provided as web services. Okay, so I'm going to now stop sharing, right? And again, thank you very much for listening to this presentation. And I'll be continuing to record, more presentations. As I said, I've got some action items from here to talk about things like secure cloud, more details, and secure IoT, and number of other topics like trustworthy machine learning. And so in future lectures, I'll be presenting them. And I'm also, this is not just it's for current state of the art as well as some of the future work, but I'm also focusing on the past, because there has to be some way to not to forget about the past. So if you look at my presentations, I've talked about multi-level secure database systems, because now in security, we hardly talk about them, but they are really important, because all of that has contributed in a way to where we are now. So I do talk about the past, I talk about the present, and I also talk about the future. And again, thank you very much for listening to this presentation. And I'm going to now stop the recording.